Hello everyone, dear authors and invited guests, welcome to Technical Session 14D. I am Dimahi Patel and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology, London, United Kingdom. The 10th edition of this conference is being organized in a hybrid mode. The physical event was held on 18th February in London, and the virtual event is being held through Zoom from 19 to 21st Feb 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for presentation and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. I would like to introduce you all to the chair for this session. We have with us Dr. Timothy Adili. Dr. Timothy is a senior lecturer in the Faculty of Engineering, University of Pretoria, South Africa. He specializes in artificial neural networks, artificial intelligence, and algorithms. With a strong academic background, Dr. Timothy contributes to cutting edge research and teaching in the field of information technology. His expertise and dedication drive innovation in AI and computational methodologies. I welcome you, sir, to the session, and I request you to share a few words to the presenters today.
Thank you so much for that introduction, Patel. I want to wish all the presenters this afternoon a wonderful presentation, and I want to believe that we're going to learn from the research that we're going to be presenting today. So I wish all the best. Thank you.
Thank you so much, sir. Now we'll be starting with the presentations. First up, I would like to call Lucas Nobrega to present their study on analyzing e-commerce customer complaints with latent semantic analysis, a case study from Brazil. Lucas, sir, are you here with me?
Yes. Let me share my screen.
Yes, sir.
Okay. Hello, everyone. First of all, let me thank you for the opportunity to attend this conference. My name is Lucas, and I'm going to present the paper analyzing e-commerce customer complaints with latent semantic analysis, a case study from Brazil. Um, Nowadays, customers share their opinions on the internet, which affects how people see brands. In e-commerce, the companies need to keep customers happy and handle complaints well to stay competitive. Some studies shows that 70% of customers check complaints before making their first purchase on a website, and 85% avoid completing a purchase if a website has a high volume of complaints. Um, in the Brazilian context, Reclame Aqui, which we can translate to complain here, is the main platform for customers to express their opinion about stores, products, and services. Um, Reclame Aqui plays a crucial role in shaping companies' reputation and also serves as a major indicator of customer satisfaction in Brazil. So the goal of this work is to understand Reclame Aqui's impact on consumer business interaction and its broader significance in Brazil. To do this, we use latent semantic analysis, or LSA, to analyze customer complaints. This approach aims to identify the main issues customers face and can give strategies to improve customers' experience and business interaction. The methodology we adopted followed this simplified flowchart with three main steps: the data extraction, data processing, and topic modeling with LSA. In the first step, the data extraction, complaints about Americanas SA, which is one of the leading companies in Brazil retail sector, were automatically retrieved from Reclame Aqui. The dataset was then built with 6 key fields: the dates on which the complaint was created, the Brazilian state where the person who created the complaint is located, the category of the complaint, for example, bad service, the category of products, for example, smartphones or TVs, the type of problem, for example, defective product or improper billing, and finally the complaint description, which is the text entered by the customer. After extracting the data, we cleaned and processed the complaints. First, we removed duplicates and empty complaints. We also excluded complaints description that were shorter than 50 characters. Then we did some text pre-processing, which included removing accents, converting the text to lowercase, removing stop words and alphabetical words, and finally we applied stemming. The last step of the methodology we apply in this work is the topic modeling with LSA. Um, First, we build a term document matrix using term frequency inverse document frequency or TF-IDF, which is a numerical value designed to reflect the importance of a term to a document in a collection. Okay. Then we apply a singular value decomposition to obtain hidden semantic terms. Um, so we selected 15 topics. We choose this number because it aligns with the number of predefined problems options provided by Americanas SA. This process forms the basis of latent semantic analysis, which help us to identify key topics in the complaints. So the topic modeling results show that the main issues in customer complaints are related to order processing, delivery, and product conditions, which account for 15% of the relevance. Payment issues, especially with Pix, which is an instantment payment system in Brazil, represent 8%. Delivery problems beyond the initial order, including cancellation and registration issues, have 7%. Account management and website navigation difficulties account for 6%. Finally, it's less prevalent, but it's equally important. Topics related to specific products and service complaints make up 5%. So these results show major challenge in logistics, order fulfillment, and payment processing for Americanas SA. Improving these areas could help them to reduce complaints and improve customer satisfaction. Additionally, our findings show how natural language processing techniques can be useful for analyzing customer complaints and identifying structural problems in e-commerce. But while these findings offer valuable insights, it is important to acknowledge some limitations of this study. This study focuses only on a single company and uses only data from Reclame Aqui, restricting the scope of the analysis. As a result, the findings may not apply to other companies, complaint platforms, or even international markets. Um, Related to that, for future work, it's necessary to expand the analysis to include other companies, platforms, and countries. This could make the study more applicable and reveal wider trends in customer dissatisfaction. Another area for improvement is integrating sentiment analysis with LSA, which could give us a deeper understanding of consumer emotions and provide more detailed insights into complaints patterns. To conclude, this study used LSA to analyze customer complaints from major Brazilian retailers, identifying key issues like logistics, order processing, and product quality. Our findings show how LSA can extract valuable insights to improve customer satisfaction and business strategies. Uh, that's it. Thank you everyone for listening. Any questions?
Thank you so much, Lucas, for that brilliant presentation. I think I have two questions for you. The first question is, during the pre-processing phase, how did you handle sentences with icons, sentences where sentences not written in English language? How did you handle that during pre-processing?
All the complaint description was in Portuguese because Reclame Aqui is a Brazilian platform, so the the analysis was all done with Portuguese. For the article, we translated to be all in English.
Oh, they're all in English. All right. Thank you so much. And my second question is, I think for your future work, it will be good for you to compare the LSA, that's your method now, to compare LSA with other methods. Because right now we can ascertain if LSA was the best approach to use. So when you then
Mm-hmm.
compare LSA with other methods using some metrics like your accuracy, precision, and some other metrics like that, it will inform you on the best possible method to use. But otherwise, it's a good research, and thank you for your presentation.
Thank you.
Thank you.
Thank you, sir. Now, next, I would like to call Islam Oshala to present their research on cross language approach for Quranic QA.
Okay. Everything is okay?
Yes, sir, we can see your screen.
Yeah. Hello, everyone. My name is Islam Mashallah, and I will present my research cross-language approach for Quranic question answering. This work was done with Muhammad Basim, Ali Hamdi, and Ammar Muhammad from my MSA University in Egypt. And this is my agenda. In the beginning, QA systems are crucial for improving access information. However, they face challenges in under resourced language like Arabic, especially when dealing with classical Arabic dialect. The Quranic QA system aims to enhance understanding of the Quranic text, holy text followed by 1.9 billion people worldwide. However, existing systems struggle with linguistic gaps between dialects and classical Arabic, making Quranic comprehension challenging for both Arabic and native and non-Arabic speakers. Additionally, the limited availability of domain-specific datasets limits model performance. Quran, Quran shared task. Our research builds upon the Quran QA 2023 shared task, which was presented at the Arabic NLB 2023 conference. Co-located with EMNLB 2023, this event is a major gathering for researchers in NLB, especially those focused on Arabic language uh, technologies. This shared task consists of two primary tasks. First, task A, passage retrieval. Given a question in modern standard Arabic, then retrieve relevant Quranic passages. Task B, extractive question answering given a passage and question. Extract the precise answer. Our research is motivated by three key factors. One, growing demand, increased interest in digital Islamic resources. Two, educational impact, supporting scholars and educators and students in Quranic studies. Linguistic challenges, addressing the gap between MSA and the classical Arabic to improve retrieval accuracy. This is my related work. They are the top three in previous shared task in 2023. The first rank was TCE at Quran QA 2023 shared task with name low resource enhanced transformer based ensemble approach for Quranic QA. They have one problem, language differences between MSA and the classical Arabic, and they have contribute with ensemble of Arabic transformer models and fine-tune the models with transfer learning and use external Arabic dataset like tafsir and 1000 QA book. The second paper was AHGL at Quran QA 2023 shared task. They have one problem too. The low dataset because they have no answering questions, number of zero answering questions. They have fine-tuned two models for retrieving Quranic QA passages and they rephrase the questions. The research limitations, the linguistic gap between MSA that used in queries and the classical Arabic that found in Quranic verses. Second, the limited dataset availability, restricting model performance, the difficulty in training models that effectively handle Quranic text complexity. The problem statement is Quran's classical Arabic poses comprehension challenges for non-Arabic speakers and native Arabic speakers unfamiliar with its style. bridging the gap between modern standard Arabic and classical Arabic. The objective is expand dataset and increase the number of questions and the diversity by rephrasing and categorizing the question, reduce the linguistic gap by translating the questions and the Quranic passages to enhance accessibility, and then fine-tuning the language models, optimize pre-trained transformers for Quranic QA task, and improving passage retrieval accuracy, enhance the precisions and recall in identifying relevant passages, especially addressing the single answering and multi-answering questions. We have used datasets from Quran QA 2023 shared task. It is about 251 questions, and used translated Quran Marmudok Big Soul. This is the translated Quranic text in English to provide a clear and faithful translation of the Quran, and supports research and analysis in Quranic question answering tasks. We have used another dataset, Squad V2 version 2 in English. It is about 150,000. They have answerable and unanswerable questions to train and evaluate machine learning models for extractive question answering and improve models' ability to handle unanswerable questions. And use Tafsir book PDF. It is about 1,000 questions from the Quran, and list of planned citations, contextual references to plant mentioned in Quran and Hadith, to learn to learn the model about the plants in Quran. Our methodology, dataset expansion by rephrase and categorized questions from another resources like the PDF 1000 QA Tafsir book, and clean the dataset by remove duplicates, data translation by to enhance the dataset and improve cross-lingual understanding. We have translated the new dataset into English using Google Translate. Randomization. To improve the dataset, we combined both positive and negative passages for each question. This ensures the model learns the relevant Quranic passages from irrelevant ones. Cross-encoder, unlike traditional retrieval methods, the cross-encoder directly analyzes the relationship between the question and the passages. It refines the ranking of passages by assigning a similarity score to improve retrieval accuracy.
Excuse me, sir.
Okay.
I'm very sorry for interruption, but this is a gentle reminder that out of 12 minutes, the 10-minute mark has crossed.
Okay, I will complete the next slides.
Yes, sir.
This is my results. we have improved the
Sir, please continue. We cannot hear you. I repeat, sir, please continue with your presentation. I believe there was some network issue. I would request everyone to wait for 1 minute. All right, till sir comes back, I would like to move on with the next presentation. Dilafroz Iskandarova, ma'am, are you present with us?
Yes, right here.
Hello, ma'am. Please start with your research on factors and prospects for the development of digital education platforms in Uzbekistan.
Okay. And see my presentation?
Yes, ma'am, we can see your screen.
Okay. Do I have to turn on camera? Is it necessary?
No, ma'am, it is not necessary. It is up to you.
Okay. Good day, respected participants. My name is Dilafroz Iskandarova, and today I will present our research on the development of digital educational platforms in Uzbekistan. Digital transformation is reshaping education globally, and Uzbekistan is no exception. Digital educational platforms offer accessibility, flexibility, and inclusivity, making education available anytime and anywhere. However, their successful implementation depends on internet coverage, digital infrastructure investments, and government policies. Is it in this study, we analyze the key factors influencing the development of digital education platforms in Uzbekistan and assess the challenges and prospects for their future growth. The global digital education market has exceeded $300 billion in 2023 and is projected to reach $1 trillion by 2030. Countries like Germany and Finland have already integrated digital learning into their educational systems. In Uzbekistan, digital education is a national priority under the Digital Uzbekistan 2030 strategy. Several platforms such as Zionet, Ustedu, and Talam Uz are actively operating, facilitating digital learning for thousands of students. However, the widespread adoption of these platforms depends on several critical factors, including first, in internet coverage, that is the availability of stable and high-speed internet. Second, investment in digital infrastructure, the development of technological infrastructure for education. Third, government policy, state support and regulatory frameworks that facilitate digital transformation in education. Okay. In the research methodology section of the article, to assess the impact of these factors, we conducted an econometric analysis using data from the Statistics Agency of Uzbekistan, the Ministry of Digital Technologies, UNICEF Uzbekistan, covering the period of 2013 to 2023. We identified the following dependent and independent variables. Dependent variables is Y, number of educational platforms, X1, independent variables are X1 is internet coverage in percent, X2 investment in digital infrastructure, X3 public policy assessment scale 1 to 100. A multiple regression model was applied to quantify the impact of these factors on the development of digital platforms. Prior to constructing an econometric model, descriptive statistics can be performed on the factors. The results data is presented in the table 1. From the data in the table, one can observe the mean, median, mode, maximum and minimum values reflecting and trends of each factor. Additionally, the table provides the standard deviation, variance, kurtosis, and skewness metrics for each factors. According to table 2, key finding in our paper. Firstly, internet coverage matters. A 1% increase in internet coverage leads to a 71.1 unit rise in the number of educational platforms. This highlights the necessity of expanding broadband and mobile internet access. Secondly, investment in digital infrastructure have a negative impact. Surprisingly, higher investment in infrastructure correlate with fewer platforms. This suggests inefficiency in fund allocation or a delay between investment and its impact on education. Thirdly, government policy plays a crucial role. A 1 unit improvement in policy assessment leads to a 10.6 unit rise in the number of platforms. Supportive policies, funding mechanisms, and regulatory frameworks significantly affect the expansion of digital education. Also, the statistical analyzed results in our study are as follows. The models are square, value is 0.99, indicating a strong correlation between the selected factors and the number of educational platforms. Fisher test and student test results confirm the model's statistical significance. Based on our findings, we propose the following recommendations. First, expand internet access. Increasing broadband coverage in rural areas is critical to ensuring equal access to digital education. Second, optimize digital investments. Investment strategies should focus on efficient implementation rather than just increasing funding. Third, strengthen government support. Policies should prioritize teacher training, curriculum digitalization, and regulatory incentives for digital education platforms, education providers. To be concluded, our study highlights the growth of digital educational platforms in Uzbekistan is strongly influenced by internet coverage, infrastructure investments, and government policies to accelerate digital transformation in education. Effective policy measures and targeted investment strategies are necessary. By addressing these factors, Uzbekistan can further enhance digital learning accessibility, improve the education quality, and align with global digital trends. Thank you for your attention. I'm happy to take any questions.
Thank you for that brilliant presentation. I like the methodology used. It's just a quick question from me. I see that you pointed out three major factors that affect the implementation of the digital platforms. My question is there any correlation or association between those three factors?
Thank you for your question. In our study, we study multi-factor econometric model, and in there three influencing factor, independent factor, impact to educational platforms, number of educational platforms, and correlation coefficient, where above 0.9, but with coefficient below 10, so we can continue this model.
All right, thank you so much for the response. Thank you.
Okay.
Thank you, ma'am, for your presentation. I would like to ask Ahmad Nasreddin, sir, to
Okay, I'm here.
present their. Yes, sir. Hello, sir.
Okay.
Please present your research on few short optimized framework for hallucination detection in resource limited NLP systems.
Okay, thank you. The screen is good.
Yes, sir.
Okay, good afternoon, everyone. My name is Ahmad Nasruddin, and today I'm excited to present our work on a few short optimized framework for detection in limited NLP systems. Presentation explore how an NLP model poses, especially with limited computational resources, and how our research aims to. So get started. So what functions? Destination outputs models that are fluent grammatically, but
Excuse me, sir.
intellect. My
I'm
Can you hear
sorry
me?
for interrupting, sir, but your voice is
No,
glitching.
no. Okay, wait a minute. I will try to change the. I stopped adding for one and I'll change the. Is my voice still glitching or?
No, sir, it is fine now.
Okay, thank you. Okay, I was saying that patients refer from NLP and correct, actually incorrect. Imagine a model stating the statement tower is this sentence is well formatted, but completely false. Gives us to research question: how can we
Um,
efficiently detect
I'm sorry, sir, but your voice is
it's
still
glitching?
glitching.
Okay.
Yes, sir. When you're starting with the presentation, your voice is starting to glitch.
No, okay. I shouldn't the any problems between me and the next one in case can the microphones it didn't I don't interrupt or you can wait. Yes, can you hear me?
Yes, sir, we can hear you.
Asking if I shift me with the next presenter so I can voice if that's possible to so I you don't wait me for long.
I'm sorry, sir, I cannot understand what you're saying right now.
I'm asking if you can me with the presenter so I can fix this sound problem so you don't wait a long time.
Oh, okay, okay. All right, sir. Yes, sir.
Okay.
Please give me a moment. Yusuf, sir, are you present with us? Yusuf Maklat, sir?
Is my voice clear?
Yes, sir. Can you please start with the presentation on retrieval augmented generation based LLM evaluation for protocol state machine inference with chain of thought reasoning?
Yes, sure. I'll start sharing my screen now.
Yes, sir.
Is my presentation clear?
Yes, sir, it is clear to us.
Okay. Okay. Hello, everyone. My name is Yusuf Makhlad, and my research paper title is Retrieval Augmented Generation Based LLM Evaluation for Protocol State Machine Inference with Chain of Thought Reasoning. Here's our agenda. We'll be going through the introduction, motivation, objective, and background. Some research challenges. We will also explain the problem statement, go through related work, then explain our knowledge base for our model, then go through the system overview, our algorithm, and the experimental design, evaluation metrics, and our results and summary of contribution. As for the introduction, network protocols are the foundation of computer networks. And typically finite state machines, they are the models that define the behavior of the protocol through a set of states, transitions, and actions, ensuring correct interaction between systems. They define the format and meaning and the order of actions of messages and message exchange among communication entities. Vulnerabilities in network protocols have emerged as a critical factor threatening the security of networks. So with the development of network applications, it's critical to find security flaws in network protocol implementations. Fuzzing or fuzz testing is an effective technique for discovering and mitigating security flaws in network protocols. As for the motivation, in stateful network protocols, uncovering security risks remain challenging till now. Due to the vast and often undocumented protocol behaviors. Large language models pose now a great capabilities in NLP tasks, and they are proven also that they have strong capabilities in generating a malicious code that would affect the security landscape. In network protocol fuzzing, achieving a comprehensive coverage across protocol states and message sequences is also challenging, which is an important motivation for us. LLMs and combined with the retrieval augmented generation techniques can enhance protocol fuzzing frameworks by inferring accurate finite state machines of the protocols. Our objective is to propose a novel LLM-based framework architecture empowered by retrieval augmented generation and chain of thought prompting techniques, typically with the React framework reason and action for accurate finite state machine inference. The second objective is to improve network packet seed generation structure quality, used to guide network protocol fuzzing frameworks towards wider exploration of protocol state space. Because if the seed structure quality is more accurate, it would lead to more code coverage, more state transitions exploration, and many other metrics used by protocol fuzzing frameworks. So speaking about the background, we will go through the classification of finite state machine extraction and inference techniques. It's classified to three techniques: static analysis, dynamic analysis, and NLP techniques. Speaking about the static analysis, it involves in analyzing the source code, protocol specifications, or the formal descriptions without executing the protocol. Its approach is by code parsing and formal method. Code parsing by parsing the source code basically to identify the state transitions. And some informal methods leveraging formal models to define and extract finite state machines. Its pros is comprehensive analysis, and it extracts and infers accurate finite state machines and no overhead, as static analysis doesn't require executing the protocol. Its cons is require access to source code, which is not the case in most cases, in most environments, and faces scalability issues due to complex protocols. Speaking about dynamic analysis, it involves observing the behavior of the protocol by executing it in a controlled environment and analyzing also its input-output interactions by either black box testing or gray box testing or symbolic execution. Speaking about the pros and cons, its pros, it has a real-time validation as the protocol is executed in real time. So we observe its IO operations and real-world edge cases. Uh, and also it's implementation agnostic and no overhead also. Its cons that it has limited coverage, high overhead as it requires the protocol under execution in a controlled environment, and also needs a protocol specific instrumentation or in other words, customization for the protocol before beginning executing. As for the NLP method, uh, it analyzes the protocol documentation to extract finite state machines and interpreting natural language description and structural artifacts from the documentation. It has rule-based parsing and machine learning and large language model-based methods. Its pros has rule-based parsing, large language model-based, and artifact mining that extracts non-textual diagrams from protocol documentation, which other techniques suffer. And cons dependence on documentation quality. Most documentation doesn't have a high quality, so this method suffers in it. Another con is context limitations of text generation models and LLM hallucinations. This is the finite state machine of the real-time streaming protocol, which is the protocol we used specifically in our work. It defines the different state transitions for a protocol and the different states that the protocol can be in. Speaking about the research challenges, there is classified into two categories. The challenges that the protocol fuzzing frameworks face and the challenges that the finite state machine techniques face. When we speak about the protocol fuzzing challenges, dependence on initial sheets, an unknown state space, and unknown message structure. As the effectiveness of the mutation-based protocol fuzzers is severely limited by the initial seed inputs, uh, which is the pre-recorded messages of network packets. If the seeds are poor, then the protocol will not achieve high code coverage. And for the finite state machine techniques issues, static analysis fall short and have scalability issues, and dynamic analysis fall short having poor coverage. NLP method fall short having facing complex protocol ambiguities, as they rely on high quality documentation, which is not the case. Our problem statement: network protocols are critical components in secure communication, yet testing their implementations for vulnerabilities and inferring accurate finite state machines remain complex and challenging. So it's essential to find security flows in protocol implementation. Our first related work is Chat AFL, Large Language Model Guided Protocol Fuzzing. It's built actually on top of AFLnet, which is the pioneering stateful network protocol fuzzer. It employs three techniques, which is seed enrichment, protocol grammar extraction, and surpassing coverage plateaus. It was evaluated on Profuzz Bench, which has an automated pipeline of an evaluation for protocol fuzzer frameworks. And here is some CVEs, common vulnerabilities and exposures that ChatAFL has discovered. And here is the results of some state transitions that ChatAFL has improved over AFLnet and NSFuzz. The second related work is ChatFuzz, which is the first framework that introduced the idea of initial seed enrichment using large language models and generative AI. ChatFuzz actually increased edge coverage by an average of 12.77 compared to AFL++ across 12, sorry, target programs. But it is important to mention that this was not network protocols, or not fuzzing network protocols, it is fuzzing text programs. Third related work is SeedMind, which is a framework that also leverages large language models for enhancing gray box fuzzing, or program fuzzing by leveraging LLMs. It utilizes LLMs to create test case generators that produce high quality format confirming inputs, improving code coverage and bug detection. And here are the results of different programs that they fuzzed, including the famous libxml and libyaml and different programs. So our knowledge base for our RAG agent is the RFC documents, short term for request for comments, published by the Internet Engineering Task Force organization. It publishes its technical documentation as RFCs. It describes the network protocol's technical foundations, such as addressing, routing, and transport technologies. This document specifically is the official documentation of the protocol. It contains the different states that the protocol might be in, the different headers, the message structure of the protocol. Our experimental design, to evaluate the agent response, we used a log dataset of RTSP-based client server interactions. These logs were typically obtained by running chat AFL on live 555 server Docker image for 2 hours. These log dataset contained around 5,000 plus entries, but we only extract the questions regarding the initial seed enrichment to begin the evaluation pipeline.
Excuse me, sir.
Yes.
This is a gentle reminder that you've crossed the 10-minute mark of the 12 minutes presentation slot of yours. All right?
Okay. Okay, I will go through it fast. This is our system overview. We begin by pre-processing the RFCs by cleaning and chunking, then embedding into the vector store. And here the evaluation pipeline begins. We use the log dataset and put it in the vector data store. We have a question about the protocol, about initial seed enrichment. Our agent queries the vector store for relevant data, and then the response given is the initial seed enriched sequences, and then it enters the evaluation. And this is our algorithm pseudocode. We begin by pre-processing, chunking into the vector store. Then our RAG React agents reason over the retrieved knowledge and then queries the vector store. And then the response is retrieved and evaluated with our evaluation metrics. And here is the prompt template for the agent, where we define the role and the goal and the system prompt for the agent, and also the task for the agent to enrich the client requests for the protocol. And this is the structure of the network packet for the real-time streaming protocol. Our evaluation metrics was rouge score, blue score, and word error rate. The experimental results show that we have improved these metrics over 18.19%, 14.81%, and 23.45% in blue, rouge, and word error rate metrics respectively over baseline models, noting that we used Gamma 2 9B model by Google and Llama 3 8B model by Meta. And these are our results. And we can see significant improvements in the different metrics after implementing the RAG and the chain of thought prompting functionality. So as the summary of contribution is that our work addresses traditional finite state machine inference problems and uses a combination of RAG and chain of thought prompted techniques to dynamically reference protocol specifications for accurate finite state machine inference and high quality network packet seed generation. Here is the references. Any questions?
Thank you so much, Yusuf. I think I only have one question. What are the
Yes.
trade-off between the complexity of your model and the computational costs in your framework?
You mean the computational or the
Cost.
cost of using the model?
Yes. Yes. No, no. In terms of when I say computational cost, the time it takes for the process to run through your algorithm during.
Yes, the time the model takes for the reasoning and querying the vector store and all that stuff. You mean that, right?
Yes, yes, yes.
Yes, there is a significant uh, like uh, like a time uh, that the agent reasons and then retrieves from the vector store the needed data, then it provides the enriched seeds. But it's important to mention that this seeds is more improved than the other enriched seeds used in other works, because other works rely on LLMs as it is, not improving it, not adding any extra methods to improve that LLMs. But we can use our method to improve the seeds and achieve high coverage. Don't care about that small time so much.
Okay. All right. Thank you.
Thank you.
Thank you, Yusuf sir.
Thank you.
Now, before we continue further, I would like to request Islam Ushala sir if they want to continue with the remaining part of the presentation now.
Okay.
They couldn't complete it because of some technical issue.
No, no, no. I will continue the presentation.
Yes, sir.
The presentation is clear?
Yes, sir. Your screen is visible to
Yes.
us.
Okay. Evaluation matrices. To assess the model performance, we use the mean average precision. It measures ranking accuracy. Then we use the mean reciprocal rank to evaluate how early correct answers appear in the ranking, recall, and the precision. Our results show significant improvements in retrieval accuracy. Roberta Bayes achieved the highest map in map 10. We achieved 34 percent, and the MRR 52%. Our contributions include developing a cross-language Quranic QA system by fine-tuning pre-trained language models, expanding the dataset for better representation and accuracy, bridging the linguistic gap between MSA dialect and classical Arabic dialect. These are references. Any question?
Timothy sir, do you have any questions for him?
I think I have one. I'm just looking at how do you handle the
Sorry,
deep.
sir, your voice is not clear.
Can you hear me now? Can you hear me?
Oh, yeah. Yes.
Yes, I think only one question here. How do you handle the difference in the dialect of the cultural variation in the Arabic
Your
language?
your voice is not clear. Sorry, sir. طب
Can you hear me now?
yes.
Yes. My question is, how do you handle differences in dialect and cultural variation of the Arabic language in your data set, from your data set?
I can't hear you.
All right, fine, we can proceed. Thank you.
What?
Okay, thank you, Islam sir, for your presentation. Now we will be moving on. Ahmed Nasreddin sir, are you with me?
Okay, I'm here, but I figured out that the connection is lost whenever I try to share screen. So can one of my colleagues, Barak Hekel, he is with us right now, can he share screen the presentation for me and I will present?
Yes, sir, that will be all right.
Okay. Okay, is my voice clear right now?
Yes, sir, your voice is clear and we can see the presentation as well.
Okay, thank you. Good afternoon, everyone. My name is Ahmed Nasruddin, and today I am excited to present our work on a few shot-optimized framework for hallucination detection in resource-limited NLP systems. In this presentation, we will explore how hallucinations in NLP models pose a challenge, especially in settings with limited computational resources, and how our approach aims to tackle this problem. So, what are hallucinations? Hallucinations refer to the outputs from NLP models that are fluent and grammatically correct, but factually incorrect. For instance, imagine a model generating the statement, "The Eiffel Tower is in Rome." This sentence is well formatted but completely false. And this brings us to our core research question: how can we efficiently detect hallucinations, especially in resource-limited NLP settings? Now let's talk about the motivation behind our work. Number one, ensuring trustworthy NLP systems. As NLP models are increasingly deployed in critical applications, ensuring their outputs are factually accurate is paramount. Hallucinations can erode trust in these systems, making robust detection mechanism essential. Number two, enhancing weak supervision. Traditional supervised learning methods require a large amount of labeled data, which is often scarce or expensive to obtain. By refining data labeling methods, particularly through weak supervision and few-shot learning, we can make models more robust even with noisy or limited inputs. Number three, tackling resource limitations. Many NLP applications operate in resource constraints environments, such as low resource languages or domains with limited computational power. Leveraging few-shot optimizations makes AI more accessible and scalable in these settings. With this motivation in mind, let's explore our approach. The problem statement: one of the biggest challenges in modern NLP is hallucinations. When language model generate fluent but incorrect outputs. This is especially problematic in high-stakes applications like healthcare, law, and finance, where misinformation can have serious consequences. The key challenges here is lack of high-quality labeled data. Existing data sets for hallucination detection are often small or noisy, making it difficult to train reliable models. And resource constraints: many real-world applications operate in an environment with limited computational resources, making it a challenges to deploy large resource-intensive models. Our work focuses on addressing these challenges by improving hallucination detection, particularly in resource-limited settings. This slide presents a comparative analysis of different hallucination detection methods in large language models, and all of them were evaluated in the SemiVal 2024 Task 6 competition. In this slide, we highlight the key challenges tackled by each approach. Some methods focus on leveraging uncertainty signals from the model, while others use external databases or prompt engineering to improve detection accuracy. The contribution to the field here, many approaches have introduced innovative techniques such as zero-shot learning, synthetic data generation, and ensemble methods to enhance hallucination detection. The performance ranking based on accuracy, the results shows that leveraging uncertainty signals, prompt engineering, and various detection techniques can significantly improve accuracy and hallucination detection. Our research outlines some key limitations in hallucination detection for LLMs. The resource-heavy sampling, some zero-resources methods are impractical for real-time use as they require extensive computational resources. And the dependencies on external APIs and databases, this reduced scalability and adaptability, particularly in resource-limited environments where access external resources may be restricted. Addressing these challenges is crucial for improving the reliability of efficiency of hallucination detection system, especially in real-world application. Our research focused on three key objectives. Number one, detecting hallucinations, improving the identification of incorrect or unsupported outputs across NLP tasks, particularly in resource-limited settings. Number two, improve weak supervision, using few-shot learning to make models more adaptable even with limited labeled data. This involves refining prompt engineering techniques to generate high-quality weak labels. Number three, enhancing the accuracy, leveraging ensemble learning strategies to improve performance and robustness. By combining multiple models, we can reduce biases and improve the all-over accuracy. This objective guide our approach to developing a scalable and efficient framework for hallucination detection. For the datasets, we are using the Shroom 2024 dataset, which were for the semi-final workshop we talked about later, which consists of the trained dataset and the dev dataset and test dataset. The trained dataset was 60,000 enabled entries for pre-training. The dev dataset was 1,000 entries for validation and fine-tuning, and the test dataset was 1,000 entries for final model evaluation. The dataset structure, like you can see, each data point contains the ID as a unique identifier, the language for the input. The model ID here is the Hugging Face model identifier. The model input is the input text to the LLM. The model output text, the model generated response, the model output text to generate response. And finally, the hard labels are the binary label indicating hallucination, 1 for hallucinated and 0 for not hallucinated. This structured dataset helps refine our hallucination detection approach. Now let's talk about our methodology. Our approach consists of 4 key steps. Number 1, the prompt engineering for weak label generation. Number 2, the dataset labeling for reconstruction. Number 3, the model fine-tuning. And number 4, the ensemble learning. Each step was designed to improve weak label quality, enhance dataset structure, fine-tune our model efficiently, and unlimitedly improve the hallucination detection performance. For number 1, the prompt engineering for weak label generation. Since hallucination detection requires precise label but lack large-scale annotated data, we use DeepSeek version 3 to generate high-quality weak labels. The baseline model accuracy was 73.6%. After specific system instructions, we managed to improve the accuracy to 77.1%. With the 8-shot prompting strategy, further increased accuracy to 82.4%, and with some iterative reinforcement. These improvements significantly enhance weak label quality. With number 2, dataset labeling and reconstruction, traditional binary classifications label don't align well with generative models. To address this, we converted dataset into a conversational Q&A format, enabling the model to engage naturally with this task, improve factual and versus hallucination response detection. This restructure maximized the model's hallucination detection accuracy. And number 3, the model fine-tuning. We fine-tuned Mr. 7B using low-rank adaptation LoRa to keep the process efficient. The training configuration with the batch size 8, learning rate was 2.5, and the training steps with 500, LoRa rank was 64. By using LoRa, we adapted the model without executive computational costs, making it suitable for resource-limited environments. Finally, the number 4 was the ensemble learning. Instead of relying on a single fine-tuned model, we combine multiple trained checkpoints and aggregate their prediction. This helps us to increase the robustness and accuracy, improve the performance consistency. This ensemble approach made our framework more stable, scalable, and reliable. This is the diagram that shows what I'm saying. We begin with the unlabeled training data, highlighted in red. This raw data lacks structures annotation, so we need way to generate weak supervision. So we used DeepSeek to generate weakly supervised data. We utilized DeepSeek with two strategies: the system instructions and the few-shot prompting. Then this led us to the weakly supervised data is restructured the yellow box here to make it more suitable for fine tuning. And step 4, the fine tuning with Mistral 7B. The goal here is to align model's response with high quality supervised data while keeping hallucination at check. Finally, we introduce the hallucination detector, the green box here, to analyze the flag the incorrect outputs. The data reconstruction that we talked about, we changed the data structure to this to align with the generative models. Now the results. Our approach outperformed previous methods in hallucination detection compared to the Shroom Shared Task 2024 was conducted in the semi-val workshop. We achieved 85.5 accuracy, setting a new benchmark. This bar chart compares our performance with other top competitors. As seen here, our method, highlighted in orange, stands ahead of all existing solutions, establishing a new state-of-the-art hallucination detection. In conclusion, our approach focused on improving hallucination detection through high-quality weak label using DeepSeek Visual 3 and 8 shot prompt engineering, fine-tuning Mistral 7B instruct using LoRa, restructured datasets to improve model actability, and sample learning strategies to maximize accuracy. As a result, we achieved an impressive 85.5 accuracy on the Shroom model agnostic track, setting a new benchmark in the field. Okay, and thank you for your time. I'd be happy to take any questions.
Thank you so much, Ahmed, for that brilliant presentation. I really enjoyed your work. But just one question.
Okay.
Is there any trade-off between reducing hallucination and preserving the information of the generated text?
Trade-off to what? I can.
The generated text. Remember, you generated some of the
Yes.
text. That's it. So, is there any trade-off? Did they affect the results of
No,
trading
I only take the output from the LLMs and check whether it hallucinates or not. I'm not affecting the generated response in any way.
Okay, all right. That's my question.
Okay.
Thank you.
Okay, welcome.
Okay, thank you so much, Ahmed sir.
Welcome.
Now I'd like to call Tushar Vasudev to present their research on XCMST, revolutionizing smart medical logistics with advanced humidity prediction through stacking ensemble models. Tushar sir?
Hello, am I audible?
Yes, sir.
Okay, wait. I'll uh, I'll share my screen. Am I also visible?
Yes, sir, you're visible.
Okay. Is my screen visible?
Yes, sir, your screen is visible to us.
Okay, so I'll go ahead and start. Good afternoon, everyone. My title of the presentation is XCMST Revolutionizing Smart Medical Logistics with Advanced Humidity Prediction through Stacking Ensembles Model. So this is the agenda. The first is introduction, then is literature review, methodology, system architecture, put methodology two times, sorry, data description and pre-processing, result, discussion and implication, conclusion and acknowledgement. So for the introduction, the problem statement, what I have chose for this research paper is the transportation of medical supplies like blood and vaccine requires strict environment control to maintain their quality and effectiveness. So in this, there is humidity fluctuation, temperature fluctuation, and we are focused on humidity fluctuations for now. There's also other components like air pressure and other things, but we'll focus on humidity fluctuations for now. So humidity fluctuation during the transport can lead to degradation, contamination, and spoilage of critical medical resources. And current humidity monitoring system focus on real-time tracking, but lack predictive capabilities to foresee and prevent unforeseeable conditions. Means they track in real time, but they don't do predictions. I mean, they're not really good at it. I mean, not a lot of people have tried to implement it. So, without any proactive measures, medical supplies remain vulnerable to environmental hazards, and particularly in challenging terrain and long-lasting transit time. The mention of challenging terrain is because I study in a place which is quite hilly. So while transporting medical supplies, there have been a lot of instances when it gets spoiled, or it's a challenge. It's a challenge to transport medicines here. So the objective of this study is to introduce a XGBoost ensemble for medical supplies transport. So basically, what I have done is that I have used an ensemble model using XGBoost, and I'll explain it further on in the presentation. So it's a stacking ensemble model that predicts humidity level inside the transport containers. And the model analyzes the past data and leverages multiple machine learning algorithm to provide high accurate humidity forecast. This predictive system helped take timely corrective action and ensure safer and more reliable medical logistics. So we have actually tried it. So I'll explain it. So why humidity matters in medical logistics. So uh, strictly, humidity control is essential for safe transport of vaccine, blood, and other pharmaceutical products. The optimal humidity range for most medical supplies is 30 to 50%. Deviation from this range can cause serious consequences affecting the quality of medical products that we're transporting. So, high humidity can lead to material degradation, affect packaging and sterility, cause viral clumps, making vaccine doses difficult and separate to administer. It also happens in blood where there's clumping there, and increase of microbial growth leading to contamination and reduce efficiency. So, low humidity can cause uh, reduce their potency, lead in increase of evaporation and liquid state medication and affecting their composition, and cause static buildup, which can damage the sensitivity of medical electronics if we are transporting some of them. So so there was a need for a predictive system. So current systems I have already mentioned monitors humidity in real time, meaning the action can only be taken when the problem occurs. So a lot of hospitals, what they do is that they have a dashboard to monitor in real time, but they don't have anything to tell them in advance that uh, that their medicine or vaccine or whatever they're transporting is going to like exceed the humidity mark. So predictive model like XEMST help forecasting humidity fluctuation, and it can allow proactive adjustment by anticipating environmental condition. Logistic team can implement preventive measures and reduce spoilage and loss. So this particular is critical in region with extreme climate variability, such as high altitude location or long transit duration. So basically, the hospitals where I study, where my college is located, has a lot of high altitude location and long transit duration. So it's quite common that they suffer from these kind of problems. So for the literature's review, what we have done is I have looked at some existing approaches. So linear regression, decision trees, they are simple but miss non-linear patterns. Then I've looked into random forest SVM. These are machine learning models. These are better for complex data. Even linear regression and decision tree are machine learning models. An example method like bagging boosting can improve the accuracy but have limited use in healthcare logistics. So I identified a gap, that lack of stacking example model application humidity prediction in medical transport, that it lacks. Nobody has not nobody, but a lot of people have not used stacking ensemble models for humidity predictions. So I'll explain the system architecture. So basically what we do is we collect data using IoT-enabled sensors. So we have sensors for temperature and humidity collection, and it is based inside and outside the box. That is a standard box that is used for transportation of medical supplies. So we collect both temperature and humidity, and there's a cloud storage. What it does that we use a IoT chip ESP32, and what it does, it has a GSM module, and it transmits the data to Google Cloud for easy accessibility and analytics. Now we have used machine learning models. We have pre-trained those models, and what it does is that whatever data goes to the cloud, it goes through that model and it gives predicts the future temperature and humidity level. So this is the design of the this is the flow chart, or you can say the design of our system architecture. So what there's a microcontroller, it takes temperature, humidity. It also takes the GPS, has an alarm attached to it, so that the person who's carrying it can be uh, can be alerted by the alarm. And then it has a GSM module. What it does is that sends the data on the database, which can be Google Cloud or any database. And we have a website. So there's a website where it will display the data that is being sent, the real-time data tracking that a lot of people have already implemented. Then what we have done, we have put the machine learning models. That is an ensemble model. And what it does is that it predicts the future values. Then there's the threshold we have set, and then it can send an SMS alert to people, like the threshold has been reached, to anyone, the person who's carrying it or the person who's monitoring it from a base, from a hospital, or from the place they are sending it to the another hospital. So, or to some camp or something in a remote area. So now for data set description and pre-processing. So the data set we have recorded is of 2,865 records from 17 transit scenario. So this transit scenarios, what we have done, we have two medical uh, not a hospital per se, but like a small clinic kind of a thing in our campus. So what we have done, we have sent medical supplies between those, and we have transisted it to a hospital that is also nearby. So we have completed data. The features are indoor and outdoor humidity and temperature. And then we also have some lagged variable and future projection. What we have done is the data we have collected, we have to make to train the machine learning model. What we have done, we have made some lagged variables and future projection from the data we collected from the indoor and outdoor temperature and humidity. Now we use some pre-processing technique for missing data. We use missing data imputation, lag feature creation, min-max normalization, temporal aggregation to reduce noise and enhance model accuracy. So now the result, what has happened is that there were some individual models. So I'll show you the models I have used. Yeah, I made a table about it. So SVM was the model which performed best among all the model, and it has the best, comparatively the best RMSE and R square score, whereas linear regression, decision tree, random forest kind of came close, but weren't that good. I mean, we could have taken linear regression because it has an R square score that is a bit better. But then RMSE of SPM was better, so it performed the best among all the models. And what we have done here is we have used the ensemble model. So XEM's RMSE score was even better, and R square scores improved the accuracy by over 25%, and compared it to the best individual models that has performed, that is SVM. So now this is the table I have showed. So this is the best hyperparameter RMSE and R square of the different base models. So the different base models we used were linear regression, decision tree, random forest, and SVM. So SVM was the best model, lowest error, higher accuracy. Then linear regression captures trends but lacks complexity. Then random forest is better than decision tree for ensemble learning. Benefits of better than decision tree, benefits from ensemble learning. Whereas decision tree struggles with complex patterns, but it had the highest RMSE. So uh, now moving on, this is the stacking model that we have used, the RMSE and R square scores. So the key improvement was it was 25% lower RMSE than best individual model, that is SVM, higher predictive accuracy, R square score, meaning the models explain 96% of variance in humidity level, better generalization across different transit scenarios. So the interpretation of result is XEMS to significantly outperform all the individual models by leveraging ensemble learning, lowered the RMSE, higher the R square score, and the proactive humidity control can be implemented, and it can reduce the medical supply spoilage. Now, discussion and implication. So, impacts and limitation. So, impacts are it's enhanced the predictive accuracy, improves medical logistics, especially challenging environment like Himalayan Valley. So, my college is actually located in an Himalayan Valley. So, that's why I've put environment like Himalayan Valley has been used as an example. It reduces spoilage and ensures supply chain efficiency. So, the limitation was that we have 17 scenarios. We need to expand this. And then there's IoT sensor reliability issues. There is not actually a lot of data inconsistencies, but sometimes what happens is that we actually are trying to improve the IoT sensors to make it wireless so that the data can be sent more efficiently. Sometimes there can be problems while sending the data. So it's actually connected, like ESP32 can connect IoT sensors wirelessly. We are looking into that, trying to make sure. The future work is to broaden the data set, to have it under different scenarios. We're trying to incorporate with the local hospitals to make sure that they can send the data, and we can have they can send the medicines from one hospital to another, from one state to another, so that it can broaden the data set. We want to improve the IoT reliability. We can make it wireless, and we can make sure that the data is always being transmitted. Not that we have had an issue with transmission of data till now, but we want to make it more efficient. That if there's a real-time scenario where it's being transported from state to state, there's a reliability of IoT. You need to check on that. Expand on other environmental factors like temperature and air pressure. We have taken the temperature data, but we have not implemented the model. We have to make sure that we implement a model. We find a ensample model that works better with temperature and the temperature data, and then we'll also take in the air pressure, and we'll try to like take in the air pressure and then work on it. So conclusion and acknowledgement. So XEMS demonstrate the power of ensemble learning and predictive medical logistic, ensuring safer, more efficient transport of medical supplies through advanced humidity forecasting. And for acknowledgement, I'd like to thank IIT Mandi for their financial and computational support. Thank you.
Timothy sir, any questions for him?
Yeah, I think I have two. How will your model adapt in case some of your sensors malfunction?
The model would not go through any problem. So basically what we do is that we make sure that we collect the data early on. Like what we have done in this 15 transit scenario, we sent medical supplies between the campus, between the two dispensary we have. So first we collected the data, like how the data will behave and how it will perform. Now what we have done is that after that, we have collected data, we have trained the model, we have put the model so that whatever data goes from then, we have made another iteration where we send the device which is working in real time. Now, what it does is that it sends the data and it processes it in real time and give you the output. So first, while we will be trying different transit scenario, what we will do is first we'll collect the data, then we will train the models on it, then we'll put the trained model uh, at the place where when the data is sent to the cloud, it goes to the model and we get the output. And we'll make sure that the IoT is working fine. The thing I mentioned that we need to improve the reliability of IoT is because we haven't have any problems. But the thing is that we want to make sure that it goes for a longer travel time. Even though it has traveled for like a day or two, but it has been limited to our college campus only, or to the hospital nearby, to the nearby district hospital. So what we want to do is that we want to send between different states, or like from a long duration. So we want to make sure that the IoT is reliable. Right now we have not had any problem, and if even if there's a problem with IoT, the machine learning model would work fine. It won't have any problem. It just needs the data being input all the time, and we will make sure that the IoT device is also robust. It has been robust by far.
No, all
Uh,
right, thank you so much. I think
uh,
you've answered my second question as well. Thank you.
okay, another question also.
No,
Thank
it's
you
all
so
good.
much.
Thank you, thank you.
Okay, thank you so much.
Thank you, Tushar sir. Now we'll be moving with the closing ceremony. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough, and we, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. I would request everyone to kindly cooperate with the team of ICICT 2025. I would like to thank our session chair, Professor Timothy, for chairing this session. I'm extending a token of appreciation on behalf of Team ICICT and Global Knowledge Research Foundation and partners. I request you, sir, to share any closing remarks you may have for the presenters here.
I want to say, as we are bringing this session to a close, I would like to take a moment to reflect on the engaging discussions, thought-provoking presentations, innovative ideas that have been shared today. It's a, I'll call it a privilege for me to chair this session and witness the depth of research and expertise presented by our esteemed speakers. So I would like to extend my sincere appreciation to um, the ICICT team, to the technical team for ensuring a smooth and successful session. And as we move forward with the rest of the conference, which is ending today anyway, I do say you guys should have a lovely afternoon or evening wherever you are. And thank you so much for this lovely session. Thank you.
Thank you, sir. Now, before we conclude this session, I kindly request everyone to switch on your camera for a quick snapshot of the virtual conference. I repeat, everyone, please turn on your camera for a quick moment. All right, thank you, everyone. Have a great day ahead and take care.
Thank you. Bye.
Thank you.